Alright guys, I want to look at another type of factoring. I want to talk about how to factor the difference of two squares. Alright, so what we're looking for here, obviously, is two perfect squares, and we're looking for subtraction between them. So for example, x squared minus 4. Well, x squared is a perfect square, and 4 is 2 times 2, so it's a perfect square. And we're subtracting between them. And this will always factor using the same kind of pattern here. You take the square root of the first thing, and the square root of the second thing. One of your signs is positive, one of them is negative. Okay, so that's a really easy example there. They're not always quite as simple. For example, you may see one that looks like this. The numbers can get bigger. You can also have numbers and variables in the same part. So again, the square root of 16x squared would be 4x, and the square root of 49 would be 7. One of them is minus, one of them is plus. It doesn't really matter what order you put them in as long as you get them right. Alright, so again, these things can get infinitely complicated, really. For example, let's try this one here. Okay, remember the first thing you want to look for whenever you're trying to factor is always the GCF. So we want to check and see, does anything go into both 50, a squared, and 2? Well, 2 goes into both of those numbers because they're both even. So the first thing we want to do is factor out the 2. Okay, so we're dividing both of those numbers by 2. Then you want to look and see what's left over. Is that a difference of two perfect squares? And 25a squared and 1 are both perfect squares, and we're subtracting. So this is a difference of perfect squares, and it will factor as 5a minus 1 and 5a plus 1. Alright? So always check for a GCF first, because looking at this, well, 50 and 2 aren't perfect squares. So you may think that this won't factor, but if you pull the GCF out first, then you can see that it does. Alright. So this one looks a little bit more complicated. A plus 2 squared minus a minus 3 quantity squared. Alright. So we use a little trick here where we let u represent a plus 2, and we let the letter v represent a minus 3. So then our problem becomes u squared minus v squared, which is a lot easier to factor. That'll factor as u minus v, u plus v. The thing is that once you've got it factored, you've got to be sure that you go back and you plug in what u and v represented. Because we didn't start off with a u and v in our problem. So plugging in the u, we're going to have a plus 2 minus v, which was a minus 3, and then a plus 2 plus a minus 3. And it's always a good idea to plug things back in parentheses. That way, like in this case, we have a negative in front here. Remember to distribute the negative through to both terms. Alright, so we can simplify this down a little bit and get rid of the parentheses by distributing. Alright, and then distributing over here. While distributing the positive doesn't really do anything. And then we can combine like terms. So a minus a would be no a's. 2 and 3 would be 5. And then over here, a plus a is 2a, and 2 minus 3 would be negative 1. Okay, so your final answer, this thing, once you factor it all the way down, becomes 5 times 2a minus 1. Alright, so I've shown all my steps here. So if you're working a problem out like this, this is what I want to see on your paper. I want you to see that you've shown all of your steps, and I want to be able to follow your work through to make sure that you got the right answer. That way, if you make a mistake up here, I can still give you partial credit, even though you missed this part, for doing everything else correctly. Okay? Let's look at another one. How about that one? So notice 64 is a perfect squared, so is x squared, so is y squared, so is 25. However, this is a positive. So this has to be the difference of two squares. It doesn't work for the sum. So if you see the sum, and there's not a GCF, like in this case, the answer is just prime. Right, meaning it doesn't factor any further. Okay? Alright, let's look at another one. 16x to the 4th minus 1. Alright, so looking at this, well, 16 is a perfect square because that's 4 squared. X to the 4th is a perfect square because that's like x squared squared. And 1 is a perfect square as well. So just checking first to make sure that everything is a perfect square here. So this is going to factor. The square root of 16 we said was 4. The square root of x to the 4th would be x squared. Alright, then we have a 1 and a 1, a plus and a minus. Alright, but then notice that looking at your answer, we're not done. Because this, again, is the difference of two more perfect squares. It factors again. Okay, so this 4x squared plus 1, we can't do anything with that because it's got a plus. And over here, we can factor this one more time. It has 2x minus 1 and 2x plus 1. Okay? So always check to make sure that you may be able to go one more step when you're solving a problem. Okay? Alright. Let's look at this one. Okay, so notice here there's first a GCF. 8 goes into both of those numbers. Okay, and then x to the 8th minus 1, those are both perfect squares and we're subtracting. So that's x to the 4th minus 1 and x to the 4th plus 1. Then again, notice more perfect squares there. That's x squared minus 1 and x squared plus 1. And don't forget that we had that x to the 4th plus 1 that won't factor. And then again, we have more perfect squares. So this will factor one more time. As x minus 1 and x plus 1. And then x squared plus 1 is prime. And x to the 4th plus 1 is prime. Alright, so then this is your final answer. This is where you'd stop. Okay? Alright. I'm trying to think of if there's anything else that may throw you off. I don't think so. I think this is about really as complicated as what you'll see on the test. Alright, so there's just a couple more examples looking at difference of squares. There is one more that I want to show you. Let's say negative 81 plus x to the 2nd. We'll make it easy. So notice here that it doesn't look like we have the difference. But since this is a negative 81, we can use the commutative property of addition to switch the order and make this x squared minus 81, which factors as x minus 9 and x plus 9. Alright? Alright, so don't forget that you can switch the order if you need to. Alright, so there's a couple examples of how to factor the difference of two squares. If you have any questions, feel free to leave a comment, and I'll try to help you out. Alright, good luck.